All right, so now the other questions, what if you have product, quotient, and a more involved chain rule? Well, here we go. So again, you're focusing on the x's. I always recommend rewriting them and putting in that multiplication so that you can find out what is being multiplied and write it off to the side. So remember, with product rule, we're going to be ending up with f prime of g plus g prime of f. So it doesn't matter which is which. Derivative of x is 1. Derivative of e to the 1 over x would be e to the 1 over x, and then now we have to do the derivative of 1 over x. So this would be the same as the derivative of x to the negative 1, so that's negative 1, x to the negative 2, so negative 1 over x squared. That's what we multiply by. So we end up with that. Okay, so now let's plug that in, and it's that little cross multiply. So we end up with e to the 1 over x, and then the second one, these two. So that x is going to cancel one of them, so we end up with minus 1 over x e to the 1 over x. And you can factor that e to the 1 over x out, just like that. And there you have it. All right, let's try a quotient rule now. So same basic idea. We're going to take the top, put it here, the bottom, put it here. So derivative of e to the x is just e to the x. And then this one gets split, so 1 plus, and then e to the x. No chain rule or anything needed. Now, before up here, you notice I did not put the e to the x as a numerator. It's because at the very end, we want to factor it out. So we do the same thing here. We know that our derivative is just going to be this one times this one first. So it's derivative of the first, so e to the x, x plus e to the x. This time it's minus, and then e to the x, 1 plus e to the x, all over the bottom squared. So now if I factor that e to the x out, I end up with x plus e to the x, and I'm going to distribute that negative like that. Okay, and so you notice the e to the x and the e to the x cancel, giving me e to the x and then x minus 1 over x plus e to the x squared. See, the whole idea behind this is we already know that e to the x is just going to become itself. So if you just rewrite it, factor it out, and then there's your answer. All right, chain rule. Chain rule works the same way. You want to have that nice parenthesis. So in this situation, we want to rewrite it so that we have our nice general power form to use our chain rule. So this would become negative 4, 1 plus e to the x. Remember, that just does not change at all. And then we subtract 1. So negative 3 times derivative of the inside. So whatever your inside is, it doesn't change, but you do need to take the derivative of it. So we write it off to the side. And we take our derivative. So it's just e to the x. So we end up with that. Just like that. So you make it until you have a nice clean parenthesis so you can use the general power form. Take that little guy, write it off to the side to find its derivative, and then we just place it at the end. Now we just have to rewrite it back in its original form, which was a fraction. So the negative 4 and the e to the x all have positive exponents, but the 1 plus e to the x does not. So we move them down there, and there you have it. Now, what if they involve trig functions? Well, this works the same way as chain rule as before. So if you remember, we've got a parenthesis here, but then we also have this exponent that is also part of chain rule. So let's start with the first one first and see what we get. So we have e to the sine of 2x. Remember, we do not rewrite it, times, and then we're going to do the derivative of the inside. So dx of sine of 2x, and we're just going to keep working our way down. So the derivative of sine to the 2x would be cosine of 2x, but then we've got to do the derivative of the inside, which is 2x, which would be 2. And then we just throw them all together. So e to the sine of 2x with these two together. So I'm going to actually take and erase this and put them in front. So 2 cosine of 2x e to the sine of 2x. And then move it down a bit. Right there to get around. All right, so that's our first one. Now we're going to put a little plus sign and do it again. So this is now sine. So remember, we take the derivative of sine, which is cosine e to the 2x. And we want to, I like to bold print them. So we have a parenthesis here, but then also that exponent is a parenthesis. So we're going to be doing chain twice. So now we have the inside. So times d dx of e to the 2x. And then this should be nice and quick because we're already good at exponents. So we end up with e to the 2x times d dx of 2x, which is 2. And then we put them all together. So same thing, 2 cosine e to the 2x times e to the 2x. Now this is just an experiment in actually working these through. I got to do one more little thing here. Y prime equals. We need to put that in there. Make sure I have it on the others as well. Nope. F prime equals. We need to make sure we denote these as derivatives. And that one I did. So we're good. All right. And there you have it.